In this short video, I want to demonstrate the use of Folium. That's a very nice package inside of Python where you can create these interactive maps. And specifically, I'm going to show you how to create a heat map. Heat maps, very nice in epidemiology. Just shows the intensity or density of points on a map. Maybe you just want to just visualize how many cases cluster in a certain area. And also maybe you want to show how that changes over time. So heat map is fantastic for that. It's very easy to create Folium maps inside of a Jupyter notebook. We're going to take a look. So I've opened my notebook just for full transparency. You can see I'm using Visual Studio Code, and at the top right, I'm using a mini Conda virtual environment. I've named mine Geodata Science, and I'm running Python 3.13.7 in there. So I create these Conda environments. I've got a couple of them, one for data science, one for geospatial data science, one for mathematics, and I put various packages in each of these. So just to keep that work separate and the packages and versions of packages just separate. So let's get going. Heat maps for epidemiology using Folium. It's just a little demonstration notebook here for Folium heat maps for epidemiological data. So this is what we're going to look at. Some packages, the packages that I'm going to use specific to this notebook. We're going to talk about what spatial heat map is, generating some epidemiological data. So we're not going to import any data, we'll just generate some synthetic data. We're going to generate a base map then using Folium, and then we're going to add this heat map to our base map. We can change some of the parameters of these heat maps, and that'll just give us slightly different visualization. And then also, just for fun, we'll do a time varying heat map. How does a heat map change over time as you get different data? You can create a time varying heat map. And then just very quickly, how can you export your maps so that you can use it elsewhere? So let's go back to the top. We're going to look at the packages. Now this notebook will be available. I'll put a link to this notebook down in the description, and there you can see the different packages. I'm going to import Folium, and then from Folium plugins I'm going to import the heat map and heat map with time. So those are these two objects that we're going to create with these two functions. They create an instance of these individual objects. I'm also going to import pandas as PD, NumPy, numerical Python as NP, and GeoPandas as GPD. Now we don't strictly need this. For Folium, you don't need a GeoPandas dataset. We're actually just going to use lists of longitude and latitude. But we always keep our geospatial data in GeoPandas data frames. It just sort of makes sense. And then from the shapely.geometry module, I'm going to import the point object there, and I'm going to create some horizontal plots, two plots next to each other, and for that I'm going to use the IPy widgets. So we're going to run all of this. There we go. We see our little green check mark. So what is a spatial heat map? Well, a spatial heat map depends on points. So I have specific places on my map, a longitude and latitude that indicates something happening there. Quintessential one is, the geolocation of someone who developed some disease. And if I've got all these little points on my map, I can use points that are close to each other to generate intensity of light. And so we'll get these little hot spots where there are a lot of points close together. So it's a very visual thing. We're not doing any statistical analysis here, any geostatistics. It's just some visualization of points being close to each other. And it's that color going perhaps from red to blue, the red indicating a lot of points close to each other, and then tapers off, becomes cooler to blue, and then eventually disappears where it's not nearby any cases. So that's very good, to allow public health officials to quickly identify regions that might require more resources or interventions. So you can see this final section here. In a heat map, each data point contributes to an overall intensity of color in its vicinity, with areas of higher density appearing more prominently. So really visual representation. It helps to quickly identify patterns and trends in spatial data, and that can be very, very useful. So let's generate some epidemiological data. So that's what we're going to do in this section. So I am going to create 300 cases, and I'm just going to center them in Brooklyn, New York. And so what we're going to do is just to create some random points. So from NumPy, the random module, uniform. So I'm going to go from 40.6 to 40.7. That's my little interval in which to create random values, and I want 300 of those, and I'm going to assign that to this column called lat for latitude, and for longitude I'm going to have this interval -74 to -73.9, and I want 300 values in there. And then I'm just going to add some random weight as well. Many times your data will have weight that just might indicate, the importance or seriousness or, some attribute for that specific case at that longitude and latitude. So let's run that. And now we have a data frame. Now the next step's not necessary, but it's always just good for me to have my geospatial data inside of a geodata frame, and that's what I'm going to do here. I'm going to take each of that latitude and longitude that we've just generated at random, and I'm going to create points out of those for each of these two columns, the lon and the lat, and I'm going to zip them together as a point geometry from the Shapely package, and then I'm going to take my pandas data frame and I'm going to convert it to a geodata frame, and the geometry is going to be the set of point geometries. So let's do that there, and let's just display the first couple of rows so you can just see I have my latitude, my longitude, this random weight attribute, and then the point geometry. And strictly speaking, Folium only needs these two columns, the lat and the longitude, but as I say, I do like my data inside of GeoPandas data frames, and it has this point geometry in case I want to do something else. In this instance, not really going to be necessary, but it's there for us. So let's generate a base map in Folium. So we have this map, folium.map, that creates an object for us, or an instance of a map object. So folium.map, I'm going to assign it to a computer variable called base_map. And so let's look at the keyword arguments. The first one's going to be location, and I need to give latitude and longitude for the center of my map. So I'm going to center this on Brooklyn, New York. I'm going to start at a certain zoom. That's, how much data you're going to see. So how far are you zoomed in or zoomed out? So zoom a level of 12 to view Brooklyn is not too bad. And then I'm going to use a background called a tile. And the specific tile that I'm going to use is one that really fades into the background so it doesn't take over. It's not too busy, your map, and that's CartoDB, the positron base map. And so let's display that map. And there you can see it's quite big. Our little map there, and we can see Brooklyn, New York is right at the center. So there's the borough of Brooklyn. We can scooch up a little bit. There's Manhattan, of course, Queens up there, and New Jersey on the left-hand side. So that's quite cool. And you can see the map's not that busy. It's the positron tile. It just sort of fades in the background. It's not too busy. If you want to plot information on top of this map, it's sort of a great tile to use. So let's plot that heat map data. And so what I'm going to do here is a couple of things. I'm going to create a base map again, centered on Brooklyn, start with a zoom level of 12, and we're going to use the CartoDB positron tile again. And now I'm going to create a list of lists. So right there I'm using list comprehension. So we're going to see for index, row in GDF, our geodata frame iterate over those rows. And so for each row, I'm going to take the latitude and longitude, and that is going to be a list of lists. So every sub list in my big list is just going to be latitude, longitude, latitude, longitude. So we see we only need a list of lists. We're not actually using the geodata frame itself. Then I'm going to call this heat map function to create this object for us. The first argument is going to be this list of lists, and I'm going to start at a radius of 15 and a blur of 10 with a max zoom of 1. Later on we'll change some of these values and we'll see what the impact of that is. I've assigned this to the computer variable m, and I'll just call m, and there we go. We plot this to the screen, and there is our heat map. So what you can see with the red, there's obviously lots of points close to each other there, makes this area red, then goes to yellow, green, eventually we get to this sort of violet color right at the end, and then nothing. And so it's just this visual representation of where you can see these hotspots, a visual indication of the intensity or density, then using intensity to show the density of these points. Now I told you at the beginning we can also just use the weight, so I'm going to do list comprehension there again, going for the latitude, the longitude, but also the weight. And that's just an attribute, whatever the data is that represents that point. Maybe it is, the seriousness of that case. Maybe it is a household and how many cases were in that household. Whatever that weight attribute is, you can add that. So we're going to do the same sort of plot, but this time we're just adding the weight. And so there you can see our plot looks a little bit different now that we've added the weight. Sometimes it's best just to normalize that weight. This is a relative to each other. It's definitely not an absolute value. So there are some keyword arguments that we can change: the radius, the blur, the max zoom, and the min opacity. The radius is just the radius of each point in the heat map, affecting the spread of the color around that map. The blur is the applied to this heat map that influences the smoothness of the heat map. The maximum zoom level at which the heat map will be displayed, and then the minimum opacity of the heat map, controlling its transparency. So the only two changes I'm going to make here is to set a radius of 20 and a blur of 15 as compared to what we had before. And now you can see the map looks very differently. I've increased this radius And so these points influence, their radius of influence is a bit wider. Just to make it easier, I've just used our IPy widget here just to create these two right next to each other. And now you can see the difference. In the first one, we have a radius of 15. In the second one, we have a radius of 20. First one, a blur of 10. Second one, a blur of 15. So it makes it just smoother. And so you play with these, and these are not statistical quantities. This is just a visualization. And, you can play with these numbers depending on sort of the story that you want to tell. Let's look at time varying heat maps. So what I'm going to suggest here is that maybe you have data for every week. So you're going to have these list of lists for every week, and you can create this animated plot, and it can just show you these one following the other one. By default, it's going to be 1 frame per second. So every frame runs in a second, and that second might then show the heat map for that week. Then the next week, whatever your time frame was. And so just to create that from our synthetic data, what I'm going to do is use list comprehension again, and I'm just going to create 5 of these list of lists. And for each one, I'm just going to randomly sample 75 random values from the data that we have. Just synthesizing these 5 different lists of lists so that our map can iterate over those 5 lists of lists. Just to show you, if we use the len function to show us the length, I have 5 of these list of lists. And now the heat map with time is going to create that instance of that object. So I'm going to start off just with my base map. Nothing has changed there, but then I'm going to have heat map with time. And then I'm going to have these 5 lists of lists. Let's set a radius of 20. The autoplay is going to be true at max opacity 0.8. And then as before, I'm just going to add that to the base map. And you might have seen with the code before, you create a base map, then create some information on top of that base map, and that information is just added to. So we use the add to method, and we just add it to the base map, and then we can display that information. And there you have it. It's playing, and we can see we've got these controls here. Let's step backwards, 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 or we can just move it forwards, 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 or you can display these. And if you can imagine that, you have proper data, you can see how these changes take place over time. And so I think that's a very nice way to represent your data. And of course, finally, we can just export these. So I'm going to say m time. So this is my time series map here. I'm just going to call the save method on that object. I'm going to give the file a name and an extension HTML. So this is going to open interactively in a browser. And so you can share that with others. They can just play this animation right inside of their browser. So using Folium, as you can see, is very, very easy to do. It uses lists of longitude and latitude with or without a weight. And if you have a bunch of these, you can actually animate them. The way that it works always is you create a base map, and then you're going to call one of these objects, create one of these objects, and you're just going to use the add to method, add_to method, and you add that to your base map. And that's the way to construct these maps. So very, very useful to use base maps in epidemiology. Gives us a nice visual representation of this point pattern in our data.